Hi everyone, in this video I'm rebuilding the end cap side skirt of a Holden SSUTE. The client sent me a 3D scan and I'm reverse engineering it for 3D printing. Here are the photographs of the side skirt end cap provided by the client. The original part shows significant damage along the fixing edges. Several sections of the wall are visibly warped. This side faces the tire and you can see it's covered with dents from the gravel hits. The end cap is too damaged to be printed directly from the 3D scan. To restore its original shape, it must be remodeled in CAD. First step is to evaluate and align the 3D scan data using Cloud Compare. This bottom face is supposed to be flat, but you can see it's really warped. I need to find a way to align this warped bottom face to the XY plane, and this wall is bent inward too, so I can't use it as a reference plane. Because the round edges of the bottom face are supported by the wall, I will select 3 points along these edges to align it with the XY plane. With the bottom face aligned, and the next step is to align one straight wall to the Y-axis. So here's how I will model it. The bottom face is flat, so I will just extrude it. But the taller edge sits at a different angle, so I will need to loft it using another sketch plane and maybe even add a third plane since the top surface looks different too. For this build, I will just be using 3 commands: extrude, sweep, and loft. Before we dive in, let's check the scan quality. It's the key factor in reverse engineering. Although the holes are damaged, sharper edges would allow more accurate identification of their location. Based on this scan, the precision error appears to exceed 0.5 mm in this area. You can see all this noise along the edges, and it makes sketching the boundary tricky since the rear edge could be hidden anywhere in there. Cutting a cross section, I found double wall lines, and in some spots the thickness goes over 0.4 mm. And when looking at this cross section, the wall line breaks apart right at the round corner. The client told me they use a Revopoint scanner, and from the calibration board in the photos, it looked like it could be a Metro Y or Metro X model. Based on the scan quality, the accuracy error is likely more than 0.5 mm, which is significant when precision is critical in reverse engineering. This end cap is going to take a lot of guesswork to model, so I will export it as LAS file and convert it into RCP point cloud in AutoDesk Recap. For this project, I will be using AutoDesk Inventor to carry out the modeling. I will begin by cropping a thin slice of the point cloud to isolate and model the bottom face. Next, I will trace the boundary line along the point cloud. In certain areas, I will need to estimate the boundary position due to missing or noisy data. I then extrude the sketch upward by 3 mm to form the base geometry. At the upper edge, I make a sketch plane from the point cloud and trace the boundary lines along its cross-section. In areas where the wall appears warped, I will disregard the scan data and reconstruct it as a straight line. Next, I will create a sketch on the bottom face and offset it by 3 mm to define the wall thickness. Next, I select the 2 sketch profiles and apply the loft command to generate the solid model. Next, I apply a 5 mm fillet to the inner corner of the wall. For the outer corner, I create a sketch profile and use the sweep cut command to round the edges. The outside corner cannot be rounded with the fillet function. For the transition zone, I'm using a variable radius fillet. Then I add another fillet here, 5mm radius. Next, I create a sketch on the top of the wall and extrude it upward by 26mm. The wall thickness is set to 1.7mm. This side of the wall leans at a slight angle, so I use an extrude cut to remove the materials. I then duplicate the pocket profile from the warped wall and apply it to the straight wall for an extrude cut. I repeat the same process for the two small clips. For the final clip, I create a sketch on the warped wall and transfer it to the straight wall. For the two mounting holes at the bottom, I located their centers using the noisy point cloud, which may introduce some error. And here is the finished piece, a clean side skirt end cap, no warp, no crooked walls, ready to hit the printer. In the slicer, I oriented the model with the flat bottom face on the build plate. With this setup, supports are required for the three clips at the top of the wall and for the round corner at the base. For demonstration purpose, I printed the model in PLA. However, for the actual application on a car exterior, I would choose ABS as it sands easily and bonds well with the primer paint. My only concern with ABS is that the top wall is quite thin, and in this orientation, the layer lines may split when attaching or removing the end cap from the side skirt. The client who provides this end cap runs a YouTube channel dedicated to restoring Holden cars. If you like to see more of his work, I will include the link in the description. Alright, let's check out the print. The supports come off pretty easily, but I had to do a bit of sanding around the round corners. You can still see some support marks inside the recessed holes. This side of the wall faces the underside of the car and is flat and smooth. The clip slots printed very well despite being only 1.7mm thick. The only issue is that it feels weak if you bend it this way. If I ran this in ABS on the K2 Plus, it would come out pretty much the same as the PLA print. Okay, so here's how I go about restoring the trim. Thanks you guys for watching. I'll see you in the next video.